Hey, hello, hey guys, hey, hello, hey, hello, hey, what's up? How are you? Good, good, okay. We're gonna talk about inverse functions. Half of this is gonna be about like derivatives and stuff. Half of this is gonna be about what an inverse function is. So let's review what is an inverse function. Well, if we have f of x, so suppose we have f of x. If f to the negative 1 is an inverse, well, the notation is f to the negative 1. So this is actually the definition of an inverse function, the algebraic definition. If f and f inverse, if they are actually inverses of each other, that's how you say this, f inverse. If they are inverses of each other, then when you compose them, f of f inverse, you get out what you plug in. And if you compose them the other way, f inverse, you still get out what you plug in. Okay, that's the definition of what an inverse function is. That's the algebraic definition. You can check it by composing both ways, and if you simplify and get x every time, they're inverses. But what about graphically? Graphically, if you have a function just like f of x, I'm going to try and draw this well. Let's say this is f of x, then the inverse of f of x is just the same function but reflected over the line y equals x. Let me try and draw this. That's pretty good. F inverse of x. So graphically, inverses are just reflections of a normal function over the line y equals x. And that means a point on the regular function gets translated to a point on the inverse function. It's just swapping them around. So that's important, and I'll write down words for that. So the inverse of a function is the reflection of that function across the line y equals x. And the ordered pairs get like swapped. So if you know x comma y is on your regular function, then y comma x is on the inverse function. That's important. So that's important to write down as well. So that's just a review of Algebra 2 and I guess trig. Let's move on. I think we shall. I think so. Do you think so? Answer me. Oh no, you can't. Okay. Let's take a look. Oh, there's going to be derivative formulas. Before we actually move on to these formulas, remember that the inverse is not just 1 over. Whatever that this does not mean that. Maybe if you made that mistake before, you were probably thinking of this. This does mean that, but this is specific notation right here. This is specific notation for the inverse function. It's not like that. It's not a reciprocal. It is an inverse function. So let's talk about derivative formulas. We're going to have a regular derivative formula and stuff for the inverse trig functions. Oh my goodness. So let's think. So if you have the inverse function and you want to take the derivative, that's an apostrophe, that's a little prime mark. If you want to take the derivative of f inverse, their formula for that is 1 over the derivative of the original function composed with the inverse function normally. Wow, that's confusing. Hopefully we'll see an example of that. But if you have trig functions, trig inverses, there's formulas. And there's a pattern to remember this. You really only have to remember 3 of them, and then the other 3 are just like patterns that I think you'll be able to pick up really quickly. So I'm going to write down the first one. So the derivative of arc sine of x is 1 over the square root of 1 minus x squared. And then I'm going to say, well, the next one that you're probably wondering about is the derivative of arc cosine. And it's going to be the exact same thing, 1 over 1 minus, x squared underneath the radical, except this one has a negative, like it has the co sound, so it'll just be the same thing but negative. So we have sine, cosine. We'll do arctangent. And that one, for whatever reason, tangent to me is like there's a plus sign. This is the only one that has a plus sign. It's 1 plus x squared in the denominator. And then the derivative of arctangent. No, I mean, sorry, arccotangent, right? Because that's the next one. You take a guess. Take a guess. If I'm writing it like this, take a guess. Guess, I said. Well, hopefully you did guess, and it is the same thing except for negative. That's a plus x squared. It is exactly the same thing except for a negative. And then lastly, we have the next two, which are I'm going to say inverse secant or arcsecant. And this one, it's a weird one, but we have 1 over the absolute value of x times the square root of x squared minus 1. The way I think of this is like secant x. For whatever reason, the C sound makes me think of an x, so the x squared comes first. Same with that x out in front. It's almost like this, except for secant, I don't know, makes me think of x. And then the derivative, of course, of arccosecant is same but negative. If you have these memorized, these problems, like on the AP test, these are problems that could be really, really easy. If you don't have them memorized, it's just like a waste, and you're just like, shoot, I should have had them memorized. And I'll be like, yeah, you should have them memorized. Because we're going to have like a memorization quiz on all of them on Friday. I'm just telling you. So, that's the end of the first video. I didn't do any examples. The examples are crazy. They're not that bad for me.